Welcome back, everyone. Now let's take a look at SPSS standard scores. So z-scores, t-scores, etc. The first thing that you do on this particular assignment is you calculate standard scores the hard way. So the old school way of doing it, where you have to fill in this little formula here. In order to fill in the formula, you need each raw score. Those are in the file, so don't need to do anything for those. But you do need the mean of the raw scores and the standard deviation of the raw scores. So there's a couple ways you can get those that you just learned in the last assignment. Frequencies or descriptives, I'm going to go ahead and use descriptives. So I go to Analyze, Descriptives, Descriptives, and Descriptives. Put midterm score over there. Under Options, make sure I got the mean and make sure I got the standard deviation. They're both sort of pre-checked. So that's kind of it. Continue and OK. Output window comes up. Oops, oh Lord, let me throw it over here. There's our mean and our standard deviation, and we're supposed to round to 2 decimals. So our mean is 81.35, our standard deviation is 12.17. And the big reveal. All right, so now we're actually going to go ahead and calculate z-scores the hard way. So to do that, you kind of have to put this little formula in where using something called compute. Compute is under transform, compute variable. Here's where you put the name of the variable that you want to create. I tell you to go ahead and call it z-score or z midterm score hard way. So I'm going to just copy that and paste it in this little target variable box. Note the equals. Well, what do you want that to be equal to? Well, we want it to be equal to the z-score formula with the mean and standard deviation filled in. But you have to make sure to use parentheses on this to get it right. So this says we want it to be equal to each score minus the mean divided by the standard deviation. Midterm score minus the mean divided by the standard deviation. So let's go ahead and do that. So I want opening parentheses, midterm score, minus the mean we just calculated, 81.35, close parentheses, just to get the order of operations right, divided by 12.17, 12.17. And when I click OK, what's going to happen, so note this matches it. When I click OK, it's going to feed each and every midterm score in, subtract the mean from it, divide by the standard deviation, put it in the data file, and it'll do that for case 1, 2, 3, 4, etc. So I click OK. Note there is a new variable in here that's called Z midterm score the hard way. And these are z-scores. So you can see they're within the range of what's expected for z-scores, smallish numbers, positives, and negatives. So then there is calculating z-scores the easy way. So this is how I expect you guys to do it moving forward. To do z-scores the easy way, it turns out you can just sort of click a box and get them under descriptives. So we go to Analyze, go down to Descriptive Statistics, and then Descriptives. All we got to do is pop the variable we want. Oops, sorry. It's already in there. Midterm score in the box on the right. It's already in there for me. Click this little thing that says Save Standardized Values as Variables. That will make z-scores. And compared to the picture, looks like we got it. I don't think I tell you to get anything because you don't need it. And click OK. That's all we're going to do. And note again, there's a new variable that appeared in our file with more decimal places here, but if you round, it's basically the same things. Negative 2.58 is 2.5759, right? It would round. All right, so z-scores a hard way, the easy way. I recommend the easy way, scooching forward. So then we want to calculate t-scores for these midterm scores. So to do that, we again have to go and use compute. So this is the formula right here for converting z-scores to t-scores. Take each z-score, multiply it by 10. After you do that in parentheses, you add 50. So let's go over to transform and compute. Because there's already a bunch of stuff in here, I'm going to hit reset just to clear everything out. And I give you a name to use, T midterm score. So I'm just going to copy that on over. paste it in that target variable box. What do we want it to be equal to? Well, we want it to be equal to the following, and I'm just putting in this formula, parentheses, we want the z-score, and do I tell you which one to use? Z-score, midterm z-score, you'll use the variable z midterm score. All right, so we're going to use z midterm score right here. And then we need to do multiply, which is a little star in here. And we multiply each one by 10. So 10, close parentheses. And then whatever that multiplier turns to be, we divide then by 50. Oh, excuse me. Oh, Lord, doing great today. We add 50, according to the formula right here. Z times each z-score times 10 plus 50 will give us a t-score. So when I click OK, let's make sure it looks like this. That's super tiny, but it pretty much looks like it. So I'll click OK. Now we've got t-scores in there. That did not go right. I did something wrong because that is clearly not t-scores. T-scores aren't negative. That's the reason people like them. So let's see what I screwed up. Oh, Lord. Oh, gosh. I forgot to get rid of the divide. All right. Well, anyway, let me show you what you do when you screw up like I just did. So z midterm score times 10 plus 50. Got it. Click OK. It tells you, do you want to overwrite the variable because it already exists out there? Click OK. Those are what t-scores look like. So they were literally invented because people hate negative numbers. All right, so now I just tell you get frequencies for midterm score, z midterm score, and t midterm score under Analyze, Descriptive Statistics, and Frequencies. So I'm going to do them in the order I said to do it. So let's get midterm score first, then z midterm score, and then t midterm score. In the Statistics button, ask you to get the mean, median, and mode, measure central tendency. And what else? Standard deviation, quartiles, and skewness. So you might see a little pattern here. Standard deviation, quartiles, skewness. All right. Under charts, get a histogram. I'm going to get the normal curve on it. And finally, we're going to click OK to run this bad boy. All right. Let me get my output back on the screen. And we have a table of statistics for each of the three variables. And then we have a frequency distribution for each of the three variables. Then we got plots for each of the three variables, or histograms. Let's start answering questions. So what is the mean and standard deviation for each of the following? The original raw midterm scores. There we go. Mean midterm score, 81.35. We kind of knew that. We calculated that earlier. I bet the standard deviation is 12.17. Survey says yes, 12.17. Remember, they went into our z-score formula earlier. How about for z midterm scores? Well, z midterm scores, the mean is 0. Standard deviation is 1. So, as you might expect, given that they are z-scores. So t midterm scores, the mean is 50, standard deviation is 10. So 50 and 10 are answers. Are the means and standard deviations of the midterm z and t scores consistent with those presented in the lecture for the z and t distributions? So remember what the mean and standard deviation was of z and t distributions. For z, it was a mean of 0, standard deviation of 1. And for t-scores, it's a mean of 50, standard deviation of 10. That is what we talked about in lecture. So I think you can just say yes, something like that. That is as expected. What percentage of t midterm scores are above the t score mean of 50? All right, where are we going to get that? Well, all these like above below ones is probably a frequency distribution. So I'm going to find the frequency distribution for t-scores. There it is. And the question is, what percentage are above 50? All right. So scooting on down, no one got exactly a 50. Someone did get a 53. So this is the first score that is above 50. We got to add 10, 15, 20, 25, 40, 45, 55, 60. Looks like it's 60% if you add those up. The other way to do it, of course, is say, okay, what percentage of scores are below the mean of 50 or lower? That's 40% using the cumulative percent. 40% of scores were 47.25 or lower. 100 minus that will get you what's above it. So hopefully this says 60. Yay. All right, so what percentage of T midterm scores might you expect to be above the T score mean of 50 based on the lecture? So if you remember back to the lecture, one thing that makes normal distributions, or one of the characteristics of it, is that the mean, median, mode are the same if it is normally distributed. The actual variable you turn to those things. So I would say, what does it mean that the mean is also the median? Well, it means that 50% of scores would be above it, 50% of scores would be below it. So I would have expected 50. 50% of scores would be above the mean. We got 60. All right. So why is that? So why is it 60, not 50? Well, the answer is not too complicated, but a little complicated. So the shape of this distribution, if we look at the skewness coefficients, it's not like significantly negative. It's not an absolute value of 2 or bigger, but it's not like 0. It's not perfectly normal. So the reason that we get 60% of t-scores above the mean instead of 50% is because this thing's not perfectly normal. So it's normal enough, that's what we would say, but it's not perfectly normal. And so you end up, you don't get all the qualities of the t-distribution when things aren't perfectly normal. So what is the skewness statistic and shape for each of the following? The original raw term midterm scores. All right, let's make this quick. Each one of these, just looking across, is the same exact number, right? Negative 0.943. That is your skewness coefficient. And what shape is it? Well, the rule is if this thing is not, absolute value of this isn't 2 or bigger, we would say it's basically normal. So the answer for each one of these is negative 0.94 and normal enough, something like that. And there we go. So did converting the midterm scores into z-scores, that is the raw scores into z-scores or t-scores, change the shape of the distribution? It did not. So the skewness coefficient is exactly the same. The other way, in case you don't believe me, is you can go down and look at the plots. So there's the raw scores, z version of the raw of the scores, and t version of the scores. They're exactly the same shape. It just shifts them around. Up or down, but they are still the same shape. So hopefully you said no, turning a non-normal variable to a z or t score does not magically make it normal. That was what I was trying to get across there. So no, what percentage of students received a raw or original midterm score of 90 or higher? All these ones that are like higher or lower, we're going to find the frequency distribution. Here's for midterm scores, and we want 90 or higher, so that includes 90, right? Yep. Well, no one got a 90. So it's going to be this 91, 94, and 99. But note you got to add 1 plus 2 because 2 people got a 94. Plus 1 is 4. We got 4 people. Oh, wait, it's percentage. Okay, percentage. Oof. 5 plus 10 plus 5 is 20. 20%. So 20% of folks had a midterm score that was 90 or higher. It is 5% got a 91, 10% got a 94, and 5% got a 99. All right, what are the first, second, and third quartiles? That is the 25th, 50th, and 75th percentiles for each of the following. Well, let's check it out. So first of all, those are up here in the statistics table. Down here under percentiles, it's 73.25, 85.5, and 89.00 for the raw scores. For z-scores, it's negative 0.67 when you round it, 0.34, and 0.63. for the Z midterm scores. How about the T-scores? 43.34, 53.41, and 56.29. All right. What is the median for each of the following? All right, well, that's right here on the table. So 85.5 for the raw scores. I'm just going to do them all at one time. 0.34 for Z-scores of the midterm scores, and 53.41 for the T-scores. So far, I don't think these are too bad. Are the medians the same or different from the corresponding second quartiles, that is the 50th percentiles? I don't know. Let's go see. So was the second quartile or 50th percentile for the raw scores 85.5, 85.5? Yep, same number. How about for Z's, 0.34, 0.34? And for T's, 53.41, 53.41. They are indeed the same. So the questions are they medians same or different from the corresponding second quartiles or 50th percentiles? They are same. So that is just reinforcing the fact that the median is the score that is at the 50th percentile. It divides the distribution into 50-50. Almost done. What percentage of midterm scores are at least one standard deviation from the mean? Lord. Use the Z-score frequency distribution to find all Z greater than or equal to 1. All right. So I used to not give the hint, so that sure makes that a little bit easier. So we got to go to the Z-score frequency distribution, and we want to count all Z-scores that have an absolute value, up or down, of 1 or larger. So, and we need the percentage. So let's start here. That 2 and that 1 and that 1, these 3 are all have an absolute value that is 1 or more standard deviations from the mean. It just happens to be below the mean. So that's 5 plus 5 plus 5. 15%. How about the upper end? Because we're talking about from the mean. Well, at the upper end, we've got this score and this score are both a standard deviation or more above the mean. So 10 plus 5 is another 15. 15 here, 15 here. The answer is 30% of the midterm scores are at least one standard deviation from the mean. I think that's probably the hardest one on here so far. So finally, outliers. Probably heard the term, but what are they? They're scores that are really far from other scores in a distribution. So people do really good or really bad in terms of a midterm. The question is, are there any outliers in these data, and then what is the raw score? So obviously there is one. So the way to find this is a outlier is a Z-score that is 2 or larger. So we're looking for Z-scores, absolute values that are 2 or larger. So there was no one who sort of got a really high score, right? The highest achieving score is 1.45. But if you go to the bottom end, you can see there's a negative 2.57. This particular person really did bad on the test. So negative 2.57 is an outlier. Why? Because the absolute value of it is 2 or bigger. So then the question is, what is the raw score for this person? And there's a couple ways to figure out what score this was, like in raw score. One is to say, okay, it's the lowest score. It's got to be the lowest score. It's this person who got a 50. That doesn't really work for me. I just go to the data and I find the Z-scores, and I'm going to find that 2, which is down here, and I'm going to go over to the raw score column, 50. So yes, there was an outlier, and it was a raw score of 50. Survey says that, so excuse me, that is SPSS for standard scores. Make sure you correct your work because you're going to have an upcoming test on this, and get your assignment turned in. Remember, you get points for trying.